Welcome to Mathematical Finance. Today, we are going to explore the two primary arenas where financial instruments are bought and sold: exchange-traded markets and over-the-counter markets. Understanding how these markets operate and the mathematical risks associated with them is absolutely foundational for anyone looking to master modern finance. Let us dive in. To understand our first market type, imagine buying a suit from a large department store. You pick a standard size off the rack, pay at the cashier, and leave. It is fast, safe, and the rules are clear, but you cannot change the design. This is exactly how an exchange-traded market works. It is a centralized, highly regulated platform where standardized financial instruments are traded. Because contracts have identical sizes and expiration dates for everyone, they trade quickly. Most importantly, a central clearinghouse stands between every buyer and seller, guaranteeing the trade and completely eliminating the risk that the other person will default. Now that we understand exchange markets, let us look at the alternative. Imagine going to a private tailor instead. You negotiate every single detail, getting perfect customization. But if the tailor goes out of business, you might lose your deposit. This is the over-the-counter or OTC market. It is a decentralized network where participants trade directly over the phone or private networks. Contracts are highly customized to fit exact unique needs. However, because there is no central clearinghouse guaranteeing the trade, participants face counterparty risk. This is the very real danger that the other side will go bankrupt and fail to pay. Before we move on to the mathematics, let us see the structural difference visually. On the left, you are looking at an exchange-traded market. Notice how all buyers and sellers route their trades through the central clearinghouse building in the middle. This central hub guarantees safety. On the right, you see the over-the-counter market. Look at the web of direct connections between buyers and sellers. There is no central hub. While this allows for direct, customized negotiation, it also means that if one participant fails, the risk directly impacts their trading partners. Having seen how these markets are structured, we can now measure their differences mathematically, starting with trading costs. In both markets, dealers quote two prices to make a profit: a lower price to buy and a higher price to sell. The difference is the bid-ask spread. The formula is S equals PA minus PB. Here, S is the bid-ask spread, representing your direct cost of trading. PA is the asking price, the higher price the dealer demands when selling to you. PB is the bidding price, the lower price the dealer offers when buying from you. As the asking price increases or the bidding price decreases, the spread widens, making trading more expensive. Now that we have our formula, let us apply it to a concrete example. A retail trader wants to buy and immediately sell a standardized contract. The dealer quotes a bidding price of $2.50 and an asking price of $2.60. We are asked to calculate the transaction cost, or the spread, for this single trade. We know we need to find the difference between the two quoted prices, so we will use our bid-ask spread formula. We identify our asking price as $2.60 and our bidding price as $2.50. This sets up our equation perfectly. Continuing with our calculation, we substitute the specific numerical values into our equation. We place the $2.60 asking price first and subtract the $2.50 bidding price from it. The subtraction gives us a final spread of $0.10. Physically, this means that for every single unit the trader buys and immediately sells, they lose 10 cents to the dealer. This 10-cent difference is the unavoidable cost of doing business. In highly liquid exchange markets, this spread is usually very small, exactly as we see in this result. Beyond the immediate cost of trading, we must also mathematically measure the hidden cost of risk in OTC markets. Because there is no clearinghouse, we use the expected loss formula to measure the danger of a partner defaulting. The formula is E equals P times L times V. E stands for the expected loss in dollars. The symbol P is the probability of default, the percentage chance the other party goes bankrupt. L is the loss given default, the percentage of money actually lost if bankruptcy occurs. Finally, V is the total exposure value, the full dollar amount of the contract. If the probability of default increases, the expected financial loss grows proportionally. Let us see how this risk formula works in practice. A large corporation enters an OTC forward contract worth $1 million. The other institution has a 2% chance of going bankrupt. If they do, the corporation expects to lose 60% of the contract's value. We need to calculate the expected financial loss. To quantify this exact dollar amount of risk, we will use our expected loss formula, which combines probability, loss severity, and total exposure. We start by writing down the standard equation. E equals P times L times V. Before we can multiply these factors together, we must convert our percentages into decimals for the mathematical calculation. The probability of default is given as 2%. We divide this by 100 to write it as the decimal 0.02. Next, the loss given default is 60%. We similarly convert this to the decimal 0.60. Preparing our numbers this way is a crucial step. It ensures that when we multiply these probabilities by the total exposure, our final result will correctly represent the statistical dollar amount of the expected loss. Now we are ready to plug our specific numbers into the expected loss formula. We multiply the probability of 0.02 by the loss severity of 0.60 and finally by the total exposure of $1 million. Multiplying these three numbers together gives us $12,000. Physically, this means the company should set aside $12,000 just to cover the statistical risk of the dealer going bankrupt. Even though the contract is worth $1 million, the mathematically expected loss is much smaller because default is unlikely. In an exchange market, this expected loss would be zero. Having calculated these risks, we must understand their real-world impact. If a company needs a highly specific contract to protect against a unique business risk, they must use the OTC market because exchanges are too rigid. However, the 2008 global financial crisis demonstrated the severe dangers of unregulated OTC markets. When massive institutions defaulted, the lack of a central clearinghouse caused panic to spread rapidly through the entire global banking system. Today, strict government regulations force many OTC trades to act more like exchange trades by requiring central clearinghouses, balancing the need for customization with systemic safety. We have covered a lot of ground today. Let us summarize the most important ideas. First, exchange-traded markets offer safety and standardization through a central clearinghouse, while OTC markets offer customization but carry counterparty risk. Second, we learned that the bid-ask spread measures the direct, unavoidable cost of trading in any market. Finally, we saw how the expected loss formula quantifies the hidden danger of default in OTC trades. You now have a solid mathematical and conceptual understanding of how these two distinct market structures operate in the global economy. Great work!